How much money do you make?
So mathematicians, I have a question for you this morning. I'm going to ask you a question. This is a situation that might actually happen in your real life. And Camila, I'm going to ask you to just scoot up a little bit closer so that you can really see. So here's the question I have for you. Your parents are going to pay you $3 a day for 4 days to wash the dishes for 2 weeks. How much money do you make?
10,800,000.
So the first thing I'm going to think about, is how am I going to even begin this problem? So I'm thinking about $3 times 4 days times 2 weeks. Okay. So I'm going to ask you to take a quiet minute. I'm going to ask you to take a quiet minute to think to yourself, how would you solve this problem? I'm going to ask you to take a quiet minute to think to yourself, how might you solve this problem?
Sun up.
When you think you have an idea, put a quiet thumb at your heart. I'm looking for some more quiet thumbs. When you think you have an idea about how you might solve this problem, put a quiet thumb at your heart. When I say go mathematicians, I'm going to ask you to turn to somebody next to you and have a conversation. Okay, that's a reminder. I'm going to ask you to have a conversation with the person next to you about how you might start solving this problem. So make sure you're sitting knee to knee, and you're going to turn and talk. Ready? Go. Turn and find somebody next to you and have a conversation about this. How might you solve this problem?
Charizard.
Okay, I'm going to ask David and Mahalia to turn and talk. And why don't you come over here? Okay, all the way over here. And sit, have a seat next to Gerard. Are you guys turning and talking? How might you solve this problem? Take a look at it. $3 times 4 days times 2 weeks. What do you guys think? Okay, say more about that. And you would do that twice. What do you think about that, Isabella? Is that how you would approach the problem, or would you think about it a different way? Make sure you turn and talk, okay? Keep talking about it. Isabella, try to think about it your way you might solve
Like this. Go, Darwin. Solve the problem with mega dinosaur. You just start talking about it. You were like,
and 0. Finishing up those conversations and turning back to me. I would like to pass the pen to somebody who thinks that they could show. How do we figure this out? $3 times 4 days times 2 weeks. Wow, I have so many brave volunteers. All right, I'm going to hand the pen to Isabella to get us started. Mathematicians, I'm going to step back, and when I step back, I'm going to ask you to make sure that you're really being great listeners, because Isabella is going to may need some of your help to build on her thinking. Before we move on, Brandon, I'm going to ask you to come on over and sit on the other side of Stephanie, please. Sorry. Yeah. So let's have, if you're close to Isabella, take a small scoot back. Andres, take a small scoot back.
She's too big. Too small.
All right, Isabella. So talk to us. What are you thinking?
I am thinking of doing an array with. Should I show it?
Yeah.
Of course.
Doing an array
with.
I am thinking about doing an array with 12 in each because 3 times 4 equals 12. So after I put 12 in each box, the answer that I get, because 12 plus 12 equals 24, so the answer is 24.
So my question, Isabella, wow, it looks like you've got a great strategy to think about this problem. I'm going to have to stop for a minute and ask a couple people to sit down, all the way down in one of the 5 ways we've talked about. Thanks. Isabella, it looks like you've got a really great strategy to help yourself solve this problem. Can you talk to us a little bit about what does the 24 mean? 24 what?
$24.
$24. Does somebody in the audience, great, another classmate want to talk a little bit about what you heard Isabella say? And you can put it in your own words. Isabella, I'm going to ask you to call on somebody else to help explain what you're thinking a little bit more. Oh, sorry, before you do that, can you write your answer?
Equals 20,000.
$24 what?
$24.
Isabella, can you call on somebody who's got a quiet hand to explain your thinking in a different way or maybe add to that?
Darwin.
Yes. What? You go. Oh. No, we're done with this one. The ladders.
Oh, she did these two?
No.
And that equals 12. And 12 times 2 equals 24.
Third graders, can somebody repeat back what they heard Darwin say, maybe in their own words? And Darwin, looking for somebody who hasn't talked yet.
Oh.
David.
What do you want to just? I know that you're doing some really great thinking, and I'm wondering just what are you thinking about? You don't necessarily have to have an answer or say exactly what Darwin said, but what are you thinking about? What are you noticing?
I said X.
And Leandro and Brandon, I'm really going to ask you to notice that David is doing some thinking right now, and that we're not going to talk while he's thinking, because he has something important to say. You have another way to solve it? Do you want to go on up to the chair and give it a try? Okay. All right. Let me pass the pen. Thanks, Darwin, for adding that step. Darwin, why don't you have a switch with David and have a seat here? Okay. So you have your own space. I'm also noticing mathematicians, lots of eyes facing forward and people really following what their classmates are. And David, while you're writing, maybe you can talk to us a little bit about your thinking.
Can I just separate it?
Can you quick write it and then talk about it?
Separate it?
Oh, separate it, sure. So I heard you say you had another strategy or another idea about how to solve this problem. Is that what you said? Okay.
You could do 4. 4 times 2 equals 8.
What are you thinking about?
16 times 3 equals
David, I'm going to pause you for a minute. I know you're doing some really great thinking in your head. You want to talk to us a little bit about what you're thinking? How are you getting your answer? Where did 24 come from? How did you get 24? And then I'm going to ask another mathematician to build on your thinking.
I just put 16 times 3 and then 16 times 3 and then I added 8 to 16 and I got to 24.
And you got to 24. Mathematicians, thumb up if you agree with David. Thumb up if you agree with David. Thumb to the side if you're not sure. Okay? Thumb down if you have another idea. Okay, I see some thumbs to the side, some people who aren't sure. If you have another idea, go ahead and raise your hand. It's something to build on what David started here. So David's definitely starting to think about solving this problem in a different way. Jorge, I'm going to ask you to stand up and move over here now so that you're 100% focused. Thanks. Well, take a look at what David did, and I noticed it was super quiet when he was working so that people could really watch and notice what he was doing. David, why don't you call in somebody who can build on your thinking a little bit? You've got a really great start there.
You forgot your name. Where?
So David, calling on someone who hasn't come on up yet. Thank you. Make sure you're in a good spot where you can focus. So Leandra, were you noticing what David was thinking about?
Yeah.
Okay, can you build on what he started? What do you notice that he's done so far?
He's did 2. He did 4 on each row.
What do those 4 represent? Those are 4 what?
$4. No. 4 days.
4 days. Okay, because it looked like you looked back up at the problem and you saw that it's 4 days. So how many days? How many days is he working so far?
16.
16 days that he's worked so far. How many days does he need to work if he's working all that time?
2 weeks.
2 weeks.
So 14 days. Yeah, 14 days.
So talk about your thinking, and you can draw it if you need to, or show your thinking in another way. What are you thinking about?
Wait. Well, he can do another box of.
You're agreeing with that, Stephanie? I saw you say, yeah.
Could have done another box and it's 24.
Okay. Raise your hand if you, or let's do thumb up if you agree with what's on the screen right now. If you think that's the answer. And it's 24 what?
$24.
$24. Okay.
What was the different equation?
It's a different equation, you think? You disagree? Wow, we've got some really great thinking here. Leandra, why don't you pass the pen to somebody else? It looked like Stephanie had an idea, or Lizette, to build on that. I heard Stephanie say that she thinks maybe it's a different equation.
Lizette.
You want to go up or just talk for a minute? That's you. Okay. What are you thinking about?
That he's making a different equation. Like 4 times 2 times 3.
Can you say more about that?
Because there's 4 on the top of this line.
You want to go up and point so we know what you're talking about? Yeah, head on up there and point so we know what you're talking about.
There's 4 in this row, so that represents the 4, and the 2 represents the 2 right here, but the 3 is the 3 squares.
Somebody want to repeat what Lizette said in their own words? Lizette, thank you. Stephanie.
On the 4 represents the 4 days.
Okay.
And then the 2 rows represents the 2 weeks, and then the 3 boxes represents the dollars.
Leandro, can you pass the pen to Stephanie? Stephanie, do you think you could write that down on the paper there, and then we're going to go ahead and give this a try ourselves. Wow, lots of great thinking this morning. Leandro, thank you. Okay, so Stephanie, how would you write down what you just said? You can write it any way you want. What makes sense to you?
4 times 2 times 3.
And you said it was 4 what?
Times 2 times 3.
David was listening. What does the 4 represent, did you say?
The days.
Days. Do you want to write days underneath it so we know? 4 days.
And then 2 weeks.
And then what does the 2 represent?
The weeks.
The weeks. And how many weeks is it?
2.
Can you write weeks under there just so we know?
And then the dollar.
And then the 3 is what?
The dollars.
Dollars. Can you go ahead and write that too? Or you can just do a money sign if you want. Okay. And Stephanie, what does 4 times 2 times 3 equal? 4 days times 2 weeks times $3 equals how much money that you would make?
$24.
Go ahead and write that. Sorry, the computer's lagging a little bit. Wait, 24 what?
Dollars.
Dollars. Go ahead and write that. I know, lots to put down. We want to make sure we're keeping track of everything. Wow. All right, Stephanie, it looks like Camila has a question, and then we are going to go off and give this a try on our own. Want to call on her?
Oh, Camila.
There's one thing that no one of them understands. 16 times 3 equals 24, because that's not true. So that means that there's 16 3 times. So that means that
Yeah, it's true.
Can you repeat, Stephanie? You said, oh yeah, that's true. Can you repeat what you heard Camila say?
That the 16 means that you have to draw 3 boxes of 16 in it.
Would 3 boxes of 16 equal 24?
No.
No. So what equation could we write? Because it looked like David got a really good start. He drew those arrays, and then somebody added one more. Who added that 3rd one? Leandro added that 3rd box, right? So now we have 3 groups. How many are in each group? Is it 16 in each group? You want to go ahead and write the equation again, where that shows how many are in each group? So just right underneath what David wrote. Go ahead and write what?
Right here.
Sure, you could write it there. Do you know, what are you gonna write? If you're not sure, you can call in someone else. Is that okay, David? If she crosses it out, you're okay with that? Okay. David, why don't you say what you think it is now?
8 times 3 equals 24. 8 times 3. Yes.
Is that true? You just check that? Because we've been practicing our multiplication facts, right? So we know 8 times 3 equals?
24.
24. I heard a lot of people say that. You just passed your 3s. Yeah, we've been practicing those. Okay. Awesome. Mathematicians, before we move on, take your right hand, hold it up. Give yourself a big pat on the back. Lots of great thinking, people sharing their ideas. Thanks, Stephanie. All right, I'm going to switch with you for a minute. Okay. All right. So, eyes on me in 3, in 2, in 1, and 0. Mathematicians, I want to give you plenty of time to do some thinking on your own and with partners. So when you get back to your seats, I want you're going to start with the yellow sheet that's on the rainbow table. Jorge, what sheet are you going to start with? The yellow sheet. Is it okay to talk to other mathematicians like we were doing here on the carpet? Yes. Yes, we want you to talk to other mathematicians on the carpet or at your seats, right? To share your thinking just like we did up here. I'm going to leave this here on the screen. So you're going to start with the yellow sheet. Marcus, if you finish the yellow sheet, you're going to go on to the blue sheet. If you finish the blue sheet, you can go on to the green sheet. And if you finish all 3, you get to make up your own problem. Okay, all right. So, and if you finish your own problem, you get to make up another one. But I'm not. We'll see. I'm looking for mathematicians. I'm looking for mathematicians who are ready to get started, showing me that they're sitting in one of the 5 ways. If you're at Camila's table, please stand up and show us what you're going to do to get started. Thank you for using walking feet to grab your yellow sheet and get started. So Andres, take a look at this problem. So you just read it to me. What could you do to make this an easier problem for yourself? What do you think you would do first? You would do 5 times 4? Okay. So why don't you set that up? Would you write it as numbers, draw a picture? What do you think? And what do you know 5 times 4 equals? How did you know that? You said that really fast. You passed your 5 test, you just know that problem right off the bat. Okay, so 20 what? What does that 20 represent? It's 5 what times 5 what? 5. What does the 5 represent? It's not just 5, it's 5 what? You can look back to the problem. Oh, is it 5 weeks? Are you sure? Where can you see in the code? So it looks like David's pointing back to the paper. So it looks like the 5 represents what? 5 weeks. So if you want, you can put a W under there to label that. Okay. And then what are you thinking about for the 4? What does that represent? Dollars. And so you put a D for dollars to label that. And then what are you thinking about for the 20? What does the 20 represent? So it's 5 weeks times 4 days. Or, oh, sorry, you were right. $4. Days and dollars both start with D. How can we make that label clearer? Because I got confused. What do you want to do to make it so you know it's dollars? Okay, the DO for dollars. Okay. Or the dollar sign. Good. Okay, that works too. Good. Great. So it equals 20 what? You got it. Okay. Are you feeling stuck? Are you and Eduardo doing some talking together? Are you both feeling stuck? How could you make it an easier problem for yourself? Take a look. I'll come check in with you in a minute. Talk to each other. How could you make that an easier problem for yourself? Okay. So now you're at $20. What's your next step? Did you find out another way to solve it? Did you get the same answer? Interesting. You ready to go on to the next one? Are you doing it a third way? Ooh, interesting. I wonder if you're going to get the same answer that time too. Okay, so you're at $20. What's your last step? How are you going to get 60? Your parents are going to pay you $4 a day for 3 days to walk the dog for 5 weeks. No, he didn't forget the 3, right? So why did you do 5 times 4 first?
It's more easier.
It's easier for you, right? You did the 5 times 4 first because you said you really know your 5's facts, right? And you figured out that equaled $20. So now you're going to build on that, right? You have $20, and what are you going to do next? What's your next step? You go back to the problem. Oh, so what do you need to do then? Where? How are you going to add the 3 in there?
No way.
Is the person next to you? Are you guys not working together? Do you feel like sitting somewhere else? Do you want to work by yourself, or do you want a thought partner? Because we're doing some good thinking over here. You want to pull up a chair? Okay.
Are you serious? What?
All right, have a seat. So table 4, it's okay to be in a larger group. Darwin, it's okay to be there. Mahalia, if you want your own space, you can move over to where Gerard was, because he moved. And then if you and Isabella want to work together, you can pull up a chair, for sure. Okay, great. Hi, looks like you've got some thinking started here. I'll check in with you in a minute, and you can also take a look at some of the thinking that the other people at this table are doing. So, in fact, Andres, I know we've talked about this a few times, but could you explain what you've done to Gerard so far about your thinking? Okay, so and you said that the 5 represents what? Okay, and what does the 4 represent?
5, 6, 7, 8.
Okay. So it's $20 for how many weeks?
5, 6, 7, 8, 9, 10, 1, 2, 3, 4.
For 5 weeks. Okay. And so what's the last piece?
5, 6, 7, 8, 9, 10. And then my 4s.
So why don't you write out your next? What are you going to do next? You can draw a picture. Okay, write it down. Looks like you've got a good start there.
Well, 5 times.
So you've got $20. 20 for 3 days. $4 a day for 3 days for 5 weeks.
Finally did 3. There, see, I'm done.
What do you think?
There's milk right here.
Just don't touch it. We'll wipe it.
24.
Do you get a different answer on that one? Interesting.
I'm done with it. Me and Rashad are done.
So you're going to go get a white piece of paper and write your own problem and then solve it. Okay, so you keep those at your seat and then grab a white piece of paper and write your own problem that looks like this. Great, so grab a white piece of paper and you're going to write up your own problem. Yep.
I'm done. I got it. Wait, but I don't know what the answer is.
I wonder how you're going to figure that out. Go ahead and put your name at the top. Great, so you figured out that 10 times 2 is $20. Hey David, before you go on to that next problem, I heard you giving Andres some ideas and then you started focusing on your own work again. Andres, it seems like you're kind of stuck here, right? You're not sure what to do next. Can you and David have a conversation about what your next step might be? And you want to have a conversation too? Okay, you ready, Andres? I'm going to step out and they're going to help you, okay? All right. How's it going, guys? Looks like you've gotten a good start. You're feeling stuck.
The last one was a lot.
Oh, it was
We had
tricky.
to write 150 words.
Oh my gosh. Okay, talk to me. What are you thinking about? Great, grab a white sheet and try figuring out your own problem. You're gonna make your own
We
problem.
did it 150 times? Yeah. 150 circles?
So, Marcus, why don't you talk to me about where you guys have gotten so far?
No, not here. Each one.
Here, okay. Talk to me about it. What have you done so far?
4, 5, 6, 7, it's 50.
But then I saw that I can make a whole
3 equals 150. Because 50 plus 50 equals 100, and another 50 equals 150, right?
I know how I can solve that.
Now let's just think of ideas.
I'm gonna walk away.
You don't know the power of the dog side.
Do you need me or are you good?
Oh, you don't know the power of the dog side.
Okay, I'll come back.
That's what it says there.
How's it going over here, guys?
Each of these things would be $1.
On the third sheet?
If you're being paid $2 for 15 days, imagine this is $1 $15 bills. But if you're being paid $2 for 15 days, then you would have 2 piles of $15. And if you were being paid $3 a day for 15 days, how many piles of $15 would you have? 3. And that's 15 and 15 and 15. 45. Now, what if you were paid, oh, your parents are going to pay you $4 a day. So you want to tell me what that's going to look like?
But that doesn't mean I was
You could count it all together. So you could go, this is 15 days, 4, 8, 12, and so on. Is that what you were doing? Okay. Look. This is 15 days. If you have $1 every day, if your parents paid you $1, that would be this box. If they paid you $2, then you'd have 2 boxes of $15. If they paid you $3 a day, you have 3 boxes of $15. What's next? If they pay you $4 a day, then you'll have 4 boxes of $15.
All right, so do you want to, and if you need to get a second sheet, if you want to get a second sheet, you have more space. You can
So, you know you worked 15 days, and could you imagine your parents going, okay, the first $1, 1, 2, 3, 4, 5, 6, 15, but I promised you more than $1, so the second $1, 1, 2, 3, 4, 5, 6, 15, but I promised you more than that. And they count out 15 more dollars,
$4 for me, or
and
circle one
then,
of the
oh,
$4
we
so that I
promised
know.
you $4.
Okay, so there's a $4 right there. Great.
Count out.
Where are the 3 days?
So how many 15s will you have?
Oh, so this is a day, this is a day, this is a day. Great. Okay, and then what? All of those. What is each?
Can you write the
What does each of these represent? What does each box represent? You said each of these is a day. Sorry, you said each of these was $1, right? This is a day. One of these is a day. What's the last one? How many weeks do you have so far? You need to add one more week? Okay. right. Talk about it. Talk about what you need to do. It sounds like you've got some really good thinking going on there. Before you keep working on this problem, actually, I'm going to ask you to step back and pick any of these three, okay? And you can do the same thing, Camila, and then you can come back to this problem. Pick any of these three and see if you put the numbers in a different order, I wonder if you get the same answer. If you put the numbers in a different order, I wonder if you're going to get the same answer. Can you check it? And you can do it on any problem. You tell me? Yeah, any of those. Just if you change the order of the numbers, are you going to get the same answer? That's my question. Yes. What are you thinking about? What have you done so far? Talk to me.
That was the number of what?
So it looks like you read the problem and then it looks like you wrote an equation, right? Can you talk to me about the equation you wrote?
3 days. So that was
5 what? 5?
3 days the second week.
Wow, that's a lot to keep track of, huh? I wonder if you can make that into an easier problem for yourself. How could you make that into an easier problem? What could you do first?
So can you write the 3 times 5 up on top?
What part of this could you do first?
Okay, and now, so that
What are you
was
thinking?
15, and then you had 4. So you started with 4 times 3 times.
Okay, I have a question for you. I'm going to be your cousin, and you're going to be you. Ready? It's day 1. Here's $5. How much did you get? How much money do you have now? 5 what?
3 times 5 is 15.
Okay, that was
So
the first
you can
day.
say 15.
Now it's the second day. I'm going to give you another $5. How much do you have now? Oh, you're going to keep track. Okay, now it's a third day. How much do you have now? I just gave you another $5. Okay, now it's the next day. I give you another $5. How much do you have? Okay, now it's the next day. I give you another $5. How much do you have? Okay, now it's the next day. Gave you another $5. How much do you have?
Yeah, here's how you spell it.
30 what? 30.
$4 a day.
What am I giving you each day? $5. So you have 30
15 days and $4 a day.
dollars, right?
1, 2,
I gave you $5, and I give you another $5, and I give you another $5. $5 a day.
So the equation
For 6 days.
is 4 times 15.
Okay. How could you write that?
$4 for 15 days.
What I just did. What would you write to represent that?
Times.
You can write it in any way that makes sense to you. I gave you $5, then I gave you another $5, then I gave you another $5. How could you write that?
5 days a week.
I did that 6 times.
Do you think you could explain that?
So what would you write? $5, and then another $5. Can you start writing that? What would you write? How could you represent that? Okay, let's do it this way. How much money did you say it would be? Total?
Think about it.
If I gave you 30 what? Dollars? Go ahead and write that down. We'll figure out how to show it later.
$4 a day.
30.
So if you work 2 days, how much would that be?
Okay, but now I'm doing that for 2
I'm just
weeks.
asking a general question. If they're paying you $4 a day and you work 2 days,
Can you pick one problem and see if you can figure out how to solve it in a different way?
if you work 15 days,
If you put the numbers in, here's the question. If you put the numbers in a different order, would you get the same answer? That's what I want you to go figure out. So pick one of those problems you did.
if
Okay.
you know
So now it's going to be $30 for 2 weeks. How are you going to figure that out?
and you get paid $4 a day, then you multiply $4 times the number of days. So if you work 5 days, how much
So
would you be paid?
it's the end of the first week, and I hand you a check for the whole week. How much am I going to hand you?
$4 a day for 5 days.
I gave you $5 for 6 days. How much are you going to get? $30, right? I'm going to do that for 2 weeks.
So
this is the
if
first
you make
week.
$4 a day,
Yeah. This is the first week. Just be careful with the door.
4 times the number of days is how much money.
Okay? And what's the second week going to be?
Score.
Now it's the second week. I'm going to give you $5 a day for 6 days. How much are you going to get?
5 weeks. So how many days did you work? 5 weeks, 3 days each week.
$5 a day. $5 plus $5 plus $5 plus $5. 6 times. How much are you going to get?
Yeah, it was 15 weeks, 15 days.
30. 30 what?
And what we just found out was
30
if you paid $4,
dollars. So this is the first week. How much are you going to get the second week? You just told me.
then multiply by 4. If you paid $4 a day,
You just told me. This is the first week. Now you're doing the same thing again next week. How much are you going to have? $30. Go ahead and write it down.
Are you ready for the next one? Okay, why don't you go for it?
You look like a man when you do it like that. I don't have any. Of course.
Okay. And so how are you going to figure out how much this is all together? Okay. How did you figure that out? What did you do with these two numbers? How did you figure out it was 60? Uh-huh. Okay, go ahead and show how you did that. Tell me, just write down exactly what you told me. You got it. So you said you did a what between these? Equals. I heard him ask you to stop. Your name for your own problem. Okay, we're actually going to stop in a minute. So my challenge to you is to go back to your sheets. Please don't do that. My challenge for you is to go back to your seat sheet and pick one problem and see if you put the numbers in a different order, would you get the same answer? And then we're going to come back together. Actually, you know what, Lauren? You know what? I think we're out of time. Why don't you just see if you can put the numbers in a different order, and then I'm going to call everyone back to the carpet. All right, so Haran's going to talk to us a little bit about how she thought about this problem, and then I'm going to ask for another mathematician to add to her thinking. So Haran, talk to us about what you did here.
I did 4 times 3 on every single square.
And what do those squares represent?
The square represents 12.
12 what?
Because 12 circles.
And what do the circles represent?
Circles represent 1.
You want to ask a friend? What do the circles represent, mathematicians?
4. $4.
So Haran, what does each circle represent? $1, right? So keep going. You got a good start. Keep going.
Every single box has 12, so 12 plus 12 plus 12 is 12 plus 12. And that means it's 12 times 5, and 12 times 5
I took my big one.
Can you say that last part one more time, Haran? Sorry about that.
12 times 5 equals 60, because if you count all of them in total, they equal 60.
Now, mathematicians, I'm wondering if you put, so first of all, thumb up if you agree with Haran. Thumb up if you agree with Haran that this makes sense. I should see thumbs up from everybody. And if you're not sure, thumb to the side. If you think you need it to be explained a little bit more, thumb to the side. Could somebody else with their thumb up right now help the friends who have their thumb to the side? Because I definitely see a few friends like that. Haran, thank you so much. You can stay there for right now. Help explain this a little bit more. Okay, somebody maybe who hasn't talked yet. No, you're still thinking? Okay. Lizette.
That if you count you could count 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, and that's 12 times. But in 5, and you got to the answer.
And you got to the answer 60. Thanks for explaining that in a different way. I'm looking for a mathematician. I'm wondering if you put the numbers in a different order. So Gerard, if you multiplied, so instead of 4 times 3 times 5, what if you put the numbers in a different order? I wonder if you'd still get the same answer. I think a lot of people say yes. I wonder if somebody thinks that maybe we wouldn't get the same answer.
Because you're using the same
David, do you think we would get a different answer?
No.
You think you'd get the same answer? Gerard, I'm noticing that you're pointing and counting the numbers, and so is Jorge. Do you guys think you're going to get a different answer or the same answer?
Same answer. Because it's the same problem and the same answer.
Does anybody in the class, wait, Brandon, Sahira, does anybody think you're going to get a different answer? Anybody think you're going to get a different answer? Brandon, do you think you're going to get 60 if you change the order? You think you're going to get a different answer?
It is a different answer.
No, it isn't.
No, it isn't.
Oh, I'm hearing Darwin say he thinks it is going to be a different answer.
No, it's not. That's his thinking. That's his thinking.
Well, Jorge, do you think you could go up and switch with Haran, and would you give it a try? And change the order of the numbers and see if you get the same answer? Could you show us? Yeah? Are you feeling confident to do that? Okay. Let's go for it. So Haran, can you pass him the pen? Thanks. And Jorge is going to see if we put those numbers in a different order. I wonder if we're going to get the same answer. I heard a lot of yes, but a few I'm not sure is and a big old no. So I wonder what we're going to see. Well, let's see. So how do you want to group the numbers? What order are you going to put them in? Haran, thanks. Why don't you have a seat right there? There's a lot of space.
I did it in 5 times 3.
Okay, go ahead and write it out. How did you do it?
On the paper?
Yeah, you can write right on the paper where there's some space. And I'm going to ask all the other mathematicians to watch. I'm going to ask all the other mathematicians to watch because Jorge may need some help. And Jorge, why are you putting parentheses around 5 times 4?
Because that's the problem that I'm going to do. That's the equation that I'm going to do.
Okay. All right, so talk to us.
Then I'm going to make
Leandro.
I'm going to make 4 times 5 times 4 equals 20.
What are you thinking about doing first?
27.
You said you were going to do, what does the 5 represent? The weeks, and what does the 4 represent? The dollars. So what are you going to do first? Okay. And each box represents what?
A week.
Okay. Weeks. I notice Eduardo's eyes are really on the screen. I notice Adrian's eyes are really on the screen. They're going to be ready to help if Jorge needs help or add, if there's anything that can be added.
No.
Okay. And now what? You said those were 5 weeks. Now what?
5 times 4 is 20.
You're going to put 4 in each box, okay? And what do the 4 in each box represent? Okay?
With all of it. In all of them.
Wait, 3 lines?
Are you asking, help,
Yes.
somebody help him out?
Yes. Wow.
I heard somebody say no, and I'm hearing some people say yes.
In every box.
Lizette, why are you saying no?
Because it says 4 on 4, 5. If you took away, just forget about the 3. If you're starting with,
You can go up and point.
if you're starting with these numbers, then you're gonna do 1, 2, 3, 4, 5, and 4 of those, and 3 of those.
I wonder, okay, thumb up if you hear what Lizette is saying and you agree. Lizette is saying, let's pretend like the 3 isn't there and just focus on the 5 times 4, right? And Lizette, can you say that one more time? Just for the people who may not have heard you. And Warren, make sure you're listening.
There's supposed to be 5 here.
Why?
It says 5 times. And so 5 here. You already wrote the 5. 5 here and 5 here. So 4 of 5.
What did Jorge do? How did Jorge write it?
He did 4 times 3 times 5.
I wonder if he keeps doing that, if he's still going to get 60. Can we let him finish and see? Okay, thanks, Lizette. Jorge, keep going. Thanks, Lizette. Let's keep that in mind, what you said. We're almost done, guys. We have like 1 minute left. And then we're going to go out. You guys are doing so well. Let's keep it up. We're almost done. Adrian, sit all the way down, please, so people behind you can see. Thanks. You think he's still going to get the same answer but a different way? Let's see. He's almost done.
And the equation is different than the picture.
Hey, Brandon, I'm going to ask you to repeat what you heard in a minute, so just make sure your eyes are up here. If you need to move over a little bit, you should. Okay, so talk to us. What do you have there?
I finished all the 4s. Making 3 groups of 4.
Okay, you finished making the, what did you make?
The 3 groups of $4.
The 3 groups of $4. How many times?
3.
5.
5 times. Okay, and how much is that all together? 60. Did you count it up? Are you sure? Does anybody have a strategy does anybody have a strategy, or do you have a plan? Or hey, looks like you've got a plan. Five times 4 is 20, right? But then it's 3 times.
What's 3 times 3?
Let's give Jorge that think time. He's almost there. Okay, Jorge, good persistence. Can you call on a quiet hand? I know you're working so hard up there. It's okay. Jorge, head up. Pick a quiet hand to help you out.
Wait for what?
To help him out to finish solving this problem.
David, I choose you. You don't have to do all that thinking. You could just do. Well, you don't have to do
repeat what you just heard David say, Jorge?
I couldn't hear.
Oh, so you could say. Could you please repeat that?
Can you please repeat that? You do all the things you could have done. 5 times 4 is 20, and then 3 times 3 is 60. Well, what if he didn't know what 20 times 3 was? 20 times 3 is. If you don't need to know it, then you can just go. 4, 6. It's 63. Not 60. Well, I'm talking about 2.
Did you write it?
No.
Why not?
Do I write it?
Do you write it? Do you understand it?
Yes.
Can you repeat what David said and then you can write it down? What did you hear David say?
You have to count all of them. And you can say that 5 times 4. 5 times 4 equals 20. And then
Andres and Gerard.
20 times
So why don't you write 5 times 4 equals 20, so you keep that part.
5 times 4.
5 times 4 is 20.
And 20 times 3.
And then what was the next part? You can ask David if you're not sure.
And 20 times 3 equals 60.
Did we get the same answer even though we multiply the numbers in a different order?
Yes.
All right. Okay, I think we're done. Great job, you guys.